This video is to review solving quadratic equations by factoring. And as I talked about in the first video, which was about solving quadratic equations by graphing, the vocabulary here is very important. You will be asked to find the roots, find the solutions, find the x-intercepts, or to solve quadratics. And essentially you're being asked to do the same thing. So make sure you know that these words all mean the same thing. You're being asked, where does this quadratic equation cross the x-axis? So you have three different tools at your disposal. You can either graph the quadratic equation and see where it crosses the x-axis. You can factor the quadratic equation and come up with the solutions or the roots. And if it's not factorable, that's when you use the quadratic formula. So this video here is specifically on factoring. So we have two examples that we're going to go over. The first here says find the roots of the quadratic below. And again, we know that it's asking us to find the solutions. And what's important to know here that both with solving by factoring and the quadratic formula, our equation must equal 0. Which means we must get everything over to one side. So what I'm going to do here is I'm going to subtract this 11b from both sides. Now I want to make sure that I'm being careful with my like terms. I know that I don't have any plain b terms over here. So my equation is 7b squared minus 11b plus 4 is equal to 0. So now that I have my equation exactly as I'd like it, now is where I check to see, is it factorable? So I multiply my first number times my last number. 7 times 4 gives me 28. So I'm looking for numbers that multiply to give me 28 and add to give me the middle number, which in this case is negative 11. So those two numbers are negative 7 and negative 4, because negative times a negative will multiply to give me a positive and will add to give me the negative 11. So I rewrite my quadratic equation as 7b squared minus 7b minus 4b plus 4. Okay, remember that I'm just separating this negative 11b into two terms that would combine to give me this, but it's going to make this equation be factorable. And I group these two terms together and these two terms together, and I factor out the largest thing from these two terms that I can. So in this case, that's going to be 7b, and that leaves me with b minus 1. Now here, I could either take out a negative 4 or a positive 4, but I know I want to be left with a positive b minus 1. So that tells me I'm going to factor out a negative b so that this b is positive and that this is a minus 1. So now I know that I am writing this 7b with this negative 4, and then I would put just one of these because those have to be the same. So I have one parentheses of 7b minus 4 and one parentheses of b minus 1, and it's equal to 0. So that is what this quadratic is factored. But that isn't what the actual roots are of the quadratic. The roots mean we actually have to solve this. We have to figure out what does b equal. So because this is equal to 0 when each of these factors are equal to 0, so 7b minus 4 is a factor and b minus 1 is a factor, that means each one of these factors could potentially be equal to 0. So you would set up two different equations, 7b minus 4 equals 0, and also b minus 1 is equal to 0. And you would solve each of those. So I'm adding 4 to the other side, 7b is equal to 4. Then I'm dividing by 7, so b is equal to 4/7. So that's one of my solutions. Okay, the other one, I just add 1 to the other side, so b is equal to 1. So if you graphed this particular equation, you would see that the two places where it crosses the x-axis are at 4/7 and +1. All right, let's do one more example of this. If you wanted, you could pause the video here, you could try this one on your own, and then you could see if you got the right answer. All right, again, what's important with this quadratic is that we have to get it equal to 0. We have to get everything over to one side before we can factor it. So I'm going to start by subtracting 7n squared. So I get 6n squared minus 23n is equal to -5 minus 6n. Okay, I'm doing each of these in separate steps. Then I'm going to add my 6n to both sides. So I have 6n squared, -23 plus 6n is going to give me -17n. And then on this side, all I'm left with is that -5. So I have that last step of adding 5 to both sides will get me to 0. So my quadratic is 6n squared minus 17n plus 5 is equal to 0. So now I'm able to factor this quadratic. So I multiply 6 times 5, which gives me 30. I'm looking for numbers that multiply to give me 30 and add to give me -17. And so those two numbers are -15 and -2. Now it doesn't matter what order I write those two numbers in here when I'm factoring, you're going to get the same answer regardless. I'm going to do 6n squared minus 2n minus 15n plus 5. So I group these and group these, and I'm going to continue up here. I take out a 2n, and then I'm left with 3n minus 1. And then I take out a -5, so that I'm left with a positive 3n minus 1. So my factors are 2n minus 5 and 3n minus 1. Okay, and now remember this whole time I kind of dropped my equal to 0, which I shouldn't have. We know that this is equal to 0, so if I'm trying to solve and get the solutions, you notice that they asked me a slightly different question here, but I'm still solving the process in the same way, solving the problem in the same way. I want to find my solutions. I want to set each of these equal to 0. So 2n minus 5 equal to 0, and 3n minus 1 is equal to 0. So I add 5 to both sides, 2n equals 5, and then I divide by 2, so n is equal to 5/2. And that's one of my solutions. Now I add 1 to both sides, 3n is equal to 1, and then I divide by 3, n is equal to 1/3. So the two solutions for this quadratic equation is n equals to 5/2, n equals to 1/3, and again those two numbers correspond to where this quadratic equation would cross the x-axis. If you have more questions about solving quadratic equations by factoring, please see your math teacher.